the law of equipartition of energy. Consider a molecule of gas of mass m moving with velocity v. The kinetic energy of the molecule is given by E equal to half mv square equal to half m vx square plus vy square plus vz square, since v square equal to vx square plus vy square plus vz square equal to half m vx square plus half m vy square plus half m vz square. But the mean or average kinetic energy of a gas molecule is given by average kinetic energy equal to average of half m vx square plus average of half m vy square plus average of half m vz square equal to 3 by 2 kt. Since all the three directions, that is x-axis, y-axis and z-axis, are equally preferred, so the average kinetic energy of the gas molecule along all the three directions is equal. Thus, from equation 2, average kinetic energy in x, y and z directions, that is half mvx square equal to half mvy square equal to half mvz square equal to 1 by 2 kt. A gas molecule moving in space has 3 degrees of freedom. So, the energy associated with each gas molecule per degree of freedom is half kt. This fact is known as law of equipartition of energy. Now let's see the definition of law of equipartition of energy. According to this law, for any system in thermal equilibrium, the total energy of the system is equally distributed among its various degrees of freedom, and the energy associated with each degree of freedom per molecule is half kt. Here K equal to 1.38 into 10 power minus 23 Joule Kelvin inverse is the Boltzmann constant, and T is the absolute temperature of the system. Now let's find total energy of a system. Consider a system having n molecules. Let F be the degree of freedom of each molecule. Therefore, total degrees of freedom of the system equal to n into F. According to law of equipartition of energy, energy associated with each degree of freedom of a molecule equal to half kt. Therefore, total energy of the system equal to number of degrees of freedom multiplied by energy associated with 1 degree of freedom, or U equal to NF into half kt equal to half F RT, since Kn equal to R. Let's see specific heat of gases in terms of energy. Let's see first for monatomic gas. A monatomic gas molecule consists of a single atom, for example helium, argon, etc. A monatomic gas molecule has 3 degrees of freedom. According to the law of equipartition of energy, energy associated with each degree of freedom equal to half kt. Therefore, energy associated with one molecule equal to 3 into half kt equal to 3 by 2 kt. Total energy associated with 1 mole of a gas, U equal to 3 by 2 Na kt, where Na is the number of molecules in 1 mole of a gas, but Na into K equal to R. Hence, equation 1 becomes U equal to 3 by 2 RT. Now, molar specific heat at constant volume Cv equal to du upon dt equal to 3R upon 2. But Cp minus Cv equal to R. Therefore, Cp equal to Cv plus R equal to 3R upon 2 plus R equal to 5R upon 2. Now, gamma equal to Cp upon Cv equal to 5R upon 2 upon 3R upon 2 equal to 5 upon 3 equal to 1.67. Now let's see for diatomic gas. A diatomic gas molecule consists two atoms, for example, hydrogen, nitrogen, oxygen, etc. A diatomic gas molecule has 5 degrees of freedom at room temperature. Now, according to the law of equipartition of energy, energy associated with 1 degree of freedom equal to half kT. Therefore, energy associated with one molecule equal to 5 by 2 kT. So, total energy associated with 1 mole of a gas U equal to 5 by 2 Na kT. But Na into K equal to R, so U equal to 5 RT upon 2. Now, Cv equal to du upon dt equal to 5R upon 2, and Cp equal to Cv plus R equal to 5R upon 2 plus R equal to 7R upon 2. Therefore, gamma equal to Cp upon Cv equal to 7R upon 2 upon 5R upon 2 equal to 7 upon 5 equal to 1.4. At very high temperature, a diatomic molecule has 7 degrees of freedom. Therefore, total energy associated with 1 mole of a diatomic gas U equal to 7 RT upon 2. Therefore, Cv equal to du upon dt equal to d by dt, 7 RT upon 2 equal to 7R upon 2, and Cp equal to Cv plus R equal to 7R upon 2 plus R equal to 9R upon 2. Therefore, gamma equal to Cp upon Cv equal to 9 upon 7 equal to 1.28. This is a value